Hello and welcome to lesson number 4, Unit 6, Solving Problems with Quadratics in our grade 10 academic math class. This is part 2 of this lesson number 4. So we've done one example already where we solved. Solving, of course, different than optimizing, which we've been doing in the last 2 lessons. Optimizing, we're finding a vertex. Solving, we're trying to find an actual set of solutions. And there are 2 ways, more, but the 2 ways we're going to be using to solve quadratics in the context of these word problems is going to be by factoring or using the quadratic formula. In our first example here that we just went through in the first part of this video, we were able to factor, which is great. Let's have a look at the second one. Okay, so again, I've done a little bit of setup here just to save myself some writing. So now would be a good time if you wanted to hit pause and sort of fill this stuff in. Yeah, hit pause and then come on back and I'll just talk my way through it. Okay, you're back. Let's read the question. A factory that measures 80 meters by 120 meters is to be built on a rectangular lot. A lawn of uniform width and of equal area to the factory itself must surround the factory. Find the width of the strip of lawn. Okay, so this is a very particular type of word problem. And you'll see it when we set it up. In the same way that the first one that we did was a very particular example. It's like a right angle triangle where you're being asked to solve. This one is what I guess I would call like a uniform border problem, where you've got like a uniform something going around the outside of something else rectangular, and you're being asked to find the width of that particular border that goes around the outside, in this case a lawn. So our let statements, of course, are going to include what I've called W here. So what you'll notice is in this drawing I have a factory, it's 80 by 120, and having a border around the outside with a uniform width means that this distance here will be the same as this distance here, and that will be true of every corner. So all of those would be equal to W, so to speak, which is why we have articulated W as the first variable, so the width of the uniform strip, and it's in meters. The second is let A represent the total combined area of the lawn and factory in meters squared. So I think that that's an important thing to consider, is that the method for solving this is for us to find out the area of the whole thing. So let's start by finding the area of the actual factory. So the area of the factory, there's our factory, that's going to be 80 times 120. So let's fire that into the old calculator and see what we get. So 80 times 120, that's going to give us 9,600. So let's see, so area of the factory would be equal to 80 times 120, which is going to give us 9,600 meters square. Now what's interesting, and they say this right in the question, is that the area of the lawn is equal to the area of the factory. So if we're trying to find the area of the lawn, it would also be 9,600 square meters. So our total area then will be the 9,600 from the building plus the 9,600 from the lawn. We add those two guys together, and that's going to give us 19,200 square meters for the total area. And that's going to be important because we are going to work towards finding the area of this rectangular shape. So let's jump over to the shape for a sec. Remember, we want the area of this whole thing. So in order to calculate the area of a rectangle, the area of a rectangle is going to be the length times the width. But let's see if we can actually figure out what the length of this thing is, because we need to know what the length is here. Well, I can tell you this part here is 120 meters, and then we've got sort of a W over here, a width and a width. So if we were going to write that as sort of one expression, it would be 120 meters plus 2 of those widths. So that is our length. Let's try the same thing for width here. So on this side, what is its total width? Well, again, we know that this side here is 80, and then we have a W and another W. So if I were going to write this as a single expression, it would be 80 plus 2 W's. Now this understanding of how I generated the length and width of this combined factory and lawn around the outside is crucial to doing questions like this. So make sure you understand sort of how I arrived at 120 plus 2W and 80 plus 2W. Once you've got that under control, then we're going to start building our area. So our area is our length times our width, and we know that our length is going to be 120 plus 2 W's, and we know that our width is going to be 80 plus 2 W's, and we know that our area, which was the total area of the, remember we're talking about the factory and the lawn together, so that's the 19,200 Now we're in a position where we can expand out and create ourselves a quadratic in standard form, which we can then go on to either factor or solve using the quadratic formula. So let's start by expanding here. There's our 19,200, and now let's expand out. So we're going to do 120 times 80, we did that already, that's going to be 9,600, and then we have 240 W, and then we have 160 W, and then we have plus 4W squared. Okay, so now I'm going to bring the 19,200 over to the other side, and we're going to gather together our like terms to create ourselves our quadratic in standard form. So here we have 0, there's our 4W squared, that's going to be plus 400W, and that's going to be minus 9,600. Okay, so we have ourselves a quadratic here in standard form. We're being asked to solve it. As always, I'm going to look to draw out a common factor. So I'm going to factor out 4, which is going to leave me with W squared plus 100W minus, so that's 9,600 divided by 4 is going to give us 2,400. Okay, so now we need to see if this thing is going to be factorable. I believe it will be factorable, but let's actually do the discriminant this time. We have some time to actually do it, so let's do the discriminant. Now the discriminant is going to be b squared, oh, I'll try to make that look more like a d for discriminant. Actually, maybe there's not really any better, we'll do it up here. So let's do our discriminant. So the discriminant will be equal to our b value squared, so that will be 100 squared minus 4 times a, which is 1, times c, which is negative 2,400. And let's bang that through the calculator and see if it's a perfect square. So we have 100 squared minus 4 times 1 times negative 2,400, and that's going to give us 19,600, which we're going to square root, and that is going to give us 140. So that is going to be a perfect square, which means that we should try to factor this. If this had been something different, then we wouldn't have tried to work it this way. Okay, so we're going to go by factoring. Maybe I'll put that down too. We'll put all the bells and whistles on this one. Therefore, solve by factoring. Okay, doing great. Factoring. Okay, I'm going to do a recopy of our equation. So that's going to give us 0 equals 4 x squared minus 100x minus 2,400. Oops, I'm sorry, that's a plus 100. Oh, and I've just changed from x's over to w's. Terrible. There's our w back, and there is our plus 100. Okay, that's much better. So we know that this is going to be factorable. So we're looking for the two things that are going to multiply to give us negative 2,400, but that add to positive 100. I'm going to start with a w here. So I'm thinking that we're going to probably do 12 and 2, I think. So plus 12, or rather, sorry, plus 120 and minus 20. And again, if you're curious about how I did that, essentially I tried to ignore these two zeros here, and I worked instead with 240 and 10, if that helps. So here I have my two factors. Now I'm going to set each factor to 0. W plus 120 equals 0, and second is W minus 20 equals 0. So I'll do a little bit of transposing, bring 120 over to the other side by subtracting 120 from both sides, and bring negative 20 to the other side by adding 20 to each side. So we have a question, or we have an answer here that is inadmissible, and it's because we're talking about the width of a strip of grass in this case. So this is inadmissible. because you can't have a negative 120 meter width for the grass. So our answer then is going to be 20. And now we jump to our therefore statement. So therefore, the width of the grass strip is 20 meters. I'll try to make that look like a 0. 20 meters. And there we go. Okay, so again, a question like this, there are going to be similar ones that have a border around the outside. The secret to tackling these ones first is to recognize you're looking for total area. And we kind of just zoomed over that when we set this question up, but we're looking for the total combined area of the original rectangle and the area of the strip around the outside. And the other thing is that in this drawing, when you calculate or determine what the length and width are of this rectangle, it's going to be their original dimensions plus, or in some cases minus, but usually plus these uniform widths either on all sides or on two sides. So that's kind of the secret to the setup on this one. Hopefully this made some sense to you. We're going to do one more video for the third part, and this third part is, it's a lidless box, and that's kind of everybody's favorite. So yeah, we'll see you in part 3.